Actually, I would like to stop the test right now because they are doing good and I'm nervous what happens in the next 10 minutes. As I expect, you like thermal storage and you didn't go for break. So let me just say a bit about the aggregator setup. The first item is the model of the consumption units. And in our setup, we assume some simplified model of the units. Why? Because of these reasons you can see. First of all is the computational complexity. If we use complex model, this will increase the computational complexity, and this makes the time we need to define these power reference unacceptable in practice when we want to aggregate many units. The second reason is the information encapsulation. If we use a complex model, then we need to exchange more information, and then the information encapsulation will be difficult. And the last reason is the separation of responsibility. The aggregator would not intend, and it's out of the scope of the aggregator's responsibility to control the consumers in detail, like every pumps or every valve. So the aggregator actually doesn't need a complex model of the system. So what we assume in our setup is that, as you can also see here, we assume the consumer, which are basically thermal energy storage, as energy collector in a way that we can describe the salient feature of the TS thermal energy storage. So we can model it in this way that we have some limitation on the capacity. We have some limitation on the power we can input to the system. Also conversion from electrical power to the thermal power can be done with different rates, which will lead to different COP of the system, and we might have leakage to the surrounding. And we have also some limitation on the input valve, which means we have limitation in, we have some run-stop constraint, as I explained, for the chiller system. So basically, the last level of complexity we can assume to model the thermal storage is the piecewise linear system, and we assume two linear systems. In order to model the behavior, for example, like chiller system, we have two different modes, or for this match the reality very well. For supermarket system, the COP during the daytime and the nighttime will be much different. So in this way, we can model these also dynamics. And this model is subject to the constraint, input constraint, which means the constraint on the power, state constraint, which means, for example, in supermarket, the temperature limits, and in the chiller system, the ice tank capacity. And we also include run-stop constraint, and with these two conditions, we never ask the chiller to switch on and to be switched on and off very often. And the last item is the optimization problem at the aggregator. We assume some MPC controller at the aggregator, and since we have this constraint and because of the model, this will lead to some mixed integer MPC design at the aggregator, and at each sampling time we want to minimize the deviation from the baseline. I guess you know about the MPC controller, but it's like that at each sampling time we have power prediction, and we just apply the first one, and based on this power prediction we also can provide the information that the units needs during the activation. So that's it. I would like to say thank you to the contributors to this demo. First of all, my supervisor, Jan Dimon Benson, at Aalborg University. Oliver also helped us a lot to make connection between the things here. I would like also to say thank you to my previous supervisor, Jakob Stostrup. He's not here right now, he's in US. But the idea of demonstrating these things was from him in the first time. And also Hakan at Gonfos. That's all. Thank you.
Very convincing, Samira. Thank you very much for a very good demonstration. Well planned as well, and everything worked fine. So congratulations with that. Pardon?
We will be done in just few samples, which means 2 or 3 minutes.
Yeah, we'll stay here. There's probably some questions. Yes? Everything was very convincing. Okay.
Frank Ellison from the Danish Technological Institute. The desired power from the supermarket, from here it looks a bit fluctuating. Can you tell me a bit more on how you calculate that, or?
The desired power, yes, the desired power is fluctuating because the parameters of the supermarket are also changing during the activation. This minimum power, maximum power, and also the available capacity for up-regulating and down-regulating. But for the chiller system, it's kind of fixed, this minimum and maximum power. That's why we might have some fluctuation in the desired power from the supermarket system. And other than this, when the problem is getting infeasible, we switch to another controller which just send the previous power. This also could be a reason.
Thank you.
You're welcome.
Dieter from IBM.
Yes.
Have you done, or will you do some economic analysis, quantitative analysis of the value of this regulation power versus the capex and the operational cost of this extra equipment?
You mean in dollar or euro or?
In Danish kroner.
Yes, I would like to be more international, but not specifically in money, in Danish kroner or what other currency, but in theoretical stuff, we assume the value of the we define the flexibility of system as the energy that is stored, and in theoretical stuff, we assume to optimize the energy we consume. So the cost function we want to optimize in theoretical stuff is different from what we tried here. And there, so I think we can map the energy consumption to the Danish krona.
Maybe I have a little bit of a comment on that also. This is mainly a technology project. Of course, also you can focus on the economics in it, but just the fact that you invest in big ice tanks and custom systems makes it a little bit hard. But I know that Silas Harbo from Energinet, sorry, Dansk Energi, sorry. Silas Harbo is doing some work in these business cases. So.
And actually, after lunch, there will be a talk on how the business case looks for the supermarket side of it. So there is people looking into the economics of it.
Yes, the activation is also finished, and yes, you can see we melt this amount of ice at the chiller, and the available flexibility at the end for supermarket is like this, different from the beginning. Yeah. And we were below the maximum power for almost all the time. Yes, thank you.